In this video, I'd like to look at an L-shaped column, and the L-shaped column has got a bit of a circular shape to it. If we go to the top view, we can see that we've got a perfect end circle there and end circle there. So we can have a look at how we can detail this column. So what I want to do before we start, we'll just get a little bit of a sketch here as per usual. And what the engineer is asking for, again, it looks like we've got N12s at 300 ligatures around, and then he's got L bars closing the gaps, um, from the outside to the inside, and from the inside here to the outside, and then he's got an L just wrapping around the outside, which are also N12s at 300. And then the main vertical bars, he's got a row of 5 bars here, 5 N24s. He's got 4 N24s on that side, obviously because we already have one in the corner. And then around the arch here, he's got 3 N24s, and it's similar here, 3 N24s. Again, we've got the traditional extension by 500 with a cog at top and bottom, and a crank lap at whatever level we can make, 1.5, 2 meters. All right, so knowing that, let's see how we can detail that column. Now, also with this column, I'd like to show in terms of, let me just bring this back, in terms of this circular bar here, which really has a leg, a straight leg. It's got a perfect arch and another straight leg, and this perfect arch has got the leg length in the middle there should be 0 because it should be a perfect half circle. So let's see how we can achieve that. And what I want to do is I want to show 2 methods. The one is I want to show how we do that with rebar groups, and then I want to show the other one as a rebar set and show that we can achieve exactly the same result. So they show up as a single line in the bending schedule with the same shape code, although they would detail 2 different methods. So that is the aim. So when we head over to our level 0, which is at the bottom, I'll go into make sure we're in transparency mode. What I'll do is, as a starter, I'll do this one as a rebar group, and I'll do this one as a rebar set, and we see how they compare. Okay, so in our rebar tab, we go to rebar group. So we go to normal rebar group, and then let's go and look at settings. So the engineer is calling for a N12 as a main bar, and just remember that the N12 has a 14 actual diameter. It's going to be very important for the calc we're going to do next. Okay, and then for the class, I'm just going to make that a different color to our per usual sand color 5, just to separate it from the rebar sets so we can see the difference. And then also I'll leave all of the others for now except the target's going to be 300. I'll just change the target to 300. So with that, what I'm going to do is I'm going to start drawing the bar. So first take the ask for the part to reinforce. I'll pick the part and then take also the shape of the bar. Now, I need to get to a point on this side. So what I like to do to start, I want to start there and work my way around here. So that's going to be the first leg around here, and that's going to be the last leg. So I start on this corner, but I'm holding my control key as a temporary snap. And then when I hover over to the other side and I accept a point there, you can see that's a red line, which implies that Tekla didn't see that as a leg. The physical start point is here now. And then if I hover and I just pull, make sure that you are in the ortho mode, you can see the 90-degree and the red coming up from the red axis. I know that this length of this wall is 750. I can click, and I also know the width on this wall is 500. Click, and then back to our endpoint here. And once we're there, we can accept the shape. And now if I just tilt it over a bit, it's asking for a range. So the start of the range, again, traditionally I like to start at the bottom and end at the top. And with that, Tekla creates a U-bar that looks as follows. Now, if we look at this bar, we need to sort of try and get around this concrete. Now, if we click on this bar, we can see the Tekla's got a bending radius of 30 millimeters, and the 30 millimeters is the radius that it applies to these 2 corners. And because there's only one value here, this field could be a list field. There can be multiple values for every corner. Because there's only one value, Tekla applies that to all the corners. Now, where does the 30 come from? If we go to our rebar catalog, it's this value specified in our rebar database, so it's picking up this value. If we had a tire or a stirrup, the radius would be slightly smaller. Okay, so with that in mind, we know now that we can manipulate these radiuses. Now we've got to apply a radius such that we end up with a zero length leg. At the moment, if we look at this bar, if I just go click on there and I just go to the shape manager quickly, if we click on this bar, we can see that leg 2 as it is there now. If I just go short leg S2 straight length, is there's a value there. So our aim is to hit a zero value there. So how do we work this out? Now for that, I am going to call up my calculator so we can see how this is done. So in the calculator, we know, let me just make sure that stays on top. So what we know is if I take a F and I take a dimension from this end to this end and I place it there, and I also select the bar to see the other dimensions. Okay, so what we know is we know that we've got a concrete dimension of 500, and we also know that we've got a 25 cover top, 25 cover bottom. So those two together is 50. So if I minus 50, I've got 450. That is from the outside of this leg to the outside of this leg. Now we also know from the catalog, although this is an N12 bar, we know that the actual diameter is 14. So if we go and we say minus 14 for the leg on top, but we also minus 14 for the leg at the bottom, we end up at 422 millimeters, which is the dimension from the inside of this leg to the inside of that leg. Now the radius would just be half of that. So if we go divide by 2, we end up with a value of 211. Now, what I will do is, let me minimize that. I'll click on the bar, and in the vent radius, I'll replace that with a value of 211. And if I do that, Tekla then generates this perfectly shaped U for us. And if we then go and click on here and we head over to our shape manager again, you can see it's now picked up a different shape that looks like this. And if we just right click in our values here and we look at our S2 value, we can see we've hit a perfect zero here, which then implies that this is a perfect half circle or a perfect arch with no straight length there. And that's exactly what we try to achieve here. Also, because I started on this corner and I've got an end, the start and end value of 25, I've got to try and hit that same leg length with our rebar sets now. If we just click on that bar and we say inquire the bar itself, you can see we're aiming for a 475 leg, which is the A dimension, it's that one, yeah. And we've got a C dimension of 475, which is the bottom straight length. And then the 450 is the B dimension, which is from the outside here to the outside on top. And then our radius is 211. Our outside radius to the outside of the bar is then 225. But I mean, you can define these shapes any which way you want. Okay, so let's try and recreate this. But before we do, let's just look at our spacing quickly so that we can actually use it in the final result. So if I click here and we just go to our property pane again, we can say the front plane, which is the gap at the bottom and the gap at the top. So what we can say is we want 75 on the bottom traditionally and 50 on top, and we'll accept that. And then for our spacing, we go to an exact spacing. And again, we know from previous videos that we can use 16 at 300. And if I enter that, we're back to our usual set out of 17 bars spaced exactly at 300. And we've got a 75 at the bottom, we've got a 75 at the top, although we've only asked to cover 50. Okay, now that sort of wraps up the rebar group. So if we just click on the concrete column, we right click and we inquire the cast unit. What we now see, if we just scroll down a bit, is if we've got our bending schedule with a single line in it, and that single line calls up an R-shaped bar, and it also calls up 17 of them. So let's see how we can deal with that in rebar sets. So with that, let's go back to our, I went past our rendered view, which is this one. I'll make it transparent. I'll just redraw to make sure that we get the right color there. And if we now go to a crossing bar, and again, we'll head over to our property pane, and we can then say, because I can see from the 24, it's got the wrong value. So if I hit that and I say N12 as a main bar, because I'm looking for the 30, and then our color will go back to our traditional 5. And then the rest of the values, except for the 300 target spacing, I'll pick. And then if I hover over this edge, what I'm going to do now is, instead of accepting all of it, I'm going to start, I want to accept that one, and I want to accept this one. And then what I can do is I can just pull this back a little bit, just to somewhere, and then say OK. And that will then give us the rebar sets in the same way. And now the next thing we want to do is we actually want to make sure that our leg lengths are correct. Well, and an easy way to do that is you can see the face here is 450. We need to make that, we need to take this value and we need to make that uh, measured from the correct side, this side. We want to make that 475 mils. And then we want to do the same on the other side. So this 500, we want to make 475. And now those bars will have exactly the same leg lengths. Now all we need to do is look at the spacing vertically. So we know we want to start 75 at the bottom. We also know we want to stop 50 at the top. And our creation method, we want to do the exact spacing again. And for the exact spacing values, it's 16 at 300. And we can just say, okay, we're happy with that. Now that generates exactly the same set. Now, if we look at this bar, I'm going to click this rebar set. So just to confirm it's a rebar set. And I'll switch off the visibility of the leg faces there. And then what I'll do is I'll head over to the rebar shape manager. And it's picked up an R bar. But the difference here is we've got an arch there. You see this little green 2 here? It implies that Tekla has now picked that up as a rebar set as a perfect arch. And if we go to our values, we can see there's an S1 straight value. And then we go down, we get an S3. There is no S2. There is no leg. So Tekla has picked up that this is a perfect arc. And then again, if we just go and look at the radiuses, we just scroll down a bit, we can see there RI2, which is radius internal, is 211 millimeters. So that's the same as what we calculated on our rebar groups, but rebar sets does it automatically for you. And then our RI2 is our outer radius is 224. That's what we defined as a D dimension on our rebar sets. So with that in mind, what we can do is just close this. And we can then now go and look at our Inquire cast unit part again. And if we look at our schedule, we have one single line. We now have 17 times 2, which is 34. And look, the dimensions are exactly the same. So it's perfect. So we've managed to achieve two different styles of detailing the same shape. That one being rebar groups, and this one being rebar sets. So powerful stuff. And yes, you can do it in both styles. So now while we're in that, I'll probably just continue with rebar sets because personally I prefer them and I think they're easier to work with. So what I'm going to do here, I'll start with the outside L bar. So we go crossing. And while we've got the settings all the same, I'm just going to hover over our shape and I want to pick, I want this leg and that leg. And then I say OK, and that will generate those legs. Now, because we have them in exactly the same spot and they were placed after this rebar set, Tekla will automatically give it to us on the inside. So what we can do is enable our leg visibility. And then on this leg, we can push this into layer 1. Okay, so that will be on top of that one. We'll figure out the spacing now. Actually, let's fix up the spacing first. So we want to go one bar up. So if we look at our 75, if you add 14 to that, we're on 89. So if I say OK, you can see it lifts it up exactly above that bar. Now this bar here, let's just have a look at what's happened here. If we look at this bar, I would have thought that should be lower. So the front plane is 75. It's interesting. It looks like the way that the cover gets measured is a little bit different from between rebar sets and rebar groups. So we'll just drop that one in the beginning a little bit. So if we take off 7 mils, so if we aim for say 68, just drop it a little bit. That's half the bar diameter. So it looks like it's measuring to the outside of the bar on the groups and it's measuring to the center in terms of the set. So it doesn't matter as long as we can figure it out, it's cool. So what we can do now is to ensure that we've got consistent leg lengths on these. We can force a leg length on the rebar set. So if we click on the bar, we can then go over to our end detail. And for our end detail, make sure we load our standards in case we've made any settings we didn't want. So if we go down here, in terms of our hook, we don't want a hook, so we can just say no hook. But what we do want is we want an adjustment type on the length, and the adjustment type is a leg length, and we want to specify a hard-coded 950 millimeters. So now if we hover over that leg, and make sure if you hover over here and it doesn't light up, you've got to look at your picking mode here. So if we just go back to our single pick mode, we will get our line. And if we now say click, and on this side click as well, it's adjusted that to a leg length. And if we look at the bar, right click, inquire, we have a perfect 950 by 950 leg length forced. Okay, so that wraps up the outside L. Now the inside L, let's just get our picture back here. On the inside L, we're going from the inside all the way across to the outside. And again, yeah, from the inside all the way across to the outside. So let's see how it's done. So what I'd like to do on these, I normally go to my ground floor, which is level 0. And in here, I'll start with one of them. For instance, I'll go use the More tab, and I say I want a point input. Make sure it's linear, and then just check my values. That's all right, and we'll just leave that there at the moment and see where we get to. And then what I'll do is I'll pick a point there all the way to the outside, and then to the next snap mode there, and I say okay, I'm happy with that. And then in terms of our spacing, again, we can just start at the bottom, head up all the way to the top, and we get our rebar sets created. Now let's see quickly what's happened in terms of our spacing. First of all, again, because this bar was put in before that bar, that one gets the next layer up. So if we click on the face and we just force this back to our first layer, Tekla then will kindly give us those 2 bars on top. Now on this other end, on the outside here, we do have an issue. We need to bring that all the way back. So if we look at this, it's in phase 2. We can make this phase 1. So it brings it back to where we want it, but also we need to elevate it. We need to push it up a little bit. So what we can do with that bar is, in terms, if we click on the bar itself, let me just click on the bar, and we look at our spacing. If we add another bar diameter, which is 14, remember, always work with actuals when you work with spacing and with clash detection. If we make that 103 mils, which is another 14 mils, it puts it exactly on top of the other bar. So it's perfect. And now the only thing is we need to control these leg lengths a bit. So if I click on the bar and I go over to my end modifier, and again, I don't want a hook, but I do want a special leg. I can say on this leg, I want to guarantee a 450 leg. So I can then hover over this one. That will pull that leg back. And on the other one, I want my 950 again. So if I say 950 and I hover over this leg, I will get to 950. Now, if we just look at what's happened, if we click on that bar and we say right click, inquire, we can now see, if we look at it, we've got a 450 and a 900 leg, which is exactly what we wanted. So with that in mind, we don't have to redo that bar. What we can do now is we can click this bar. As long as we're in the XY and we're flat, we can click on the bar and say right click, copy special, mirror, and then mirror about this symmetrical line over here. And if we then say copy, it generates the exact same bar for us on the other side. And all we need to do now is just look at the if we can avoid clashes. Now, we've got a couple of layers going on here. If we move it one down to miss that bar, we're going to clash with this bar. If we move it another one down, it's going to clash with this bar and with that bar. So what we can do is we can either push this right up another 14 mils, or we can drop it to below. Now we know that the one below is a 75. So if we make this one 61, drop it one diameter down. If we make this 61, that should slot us in right at the bottom. So there we go. So this is working out really, really nice. Now, if we look at these lap perfectly and they're all in the same plane. These lap perfectly in the same plane. That laps perfectly. So the only gap we have is these two, but that's unavoidable. There's nothing you can do. So they'll probably just tie these to the vertical bars instead. But I mean, unless you just slope it down or whatever, they'll probably do that on site anyway. They don't work with water levels when they fix these reinforcements. So it's probably going to end up where it ends up. But in terms of detailing, this is as good as it's going to get. Now that we've done that, we can have a look at our bending schedule one more time. If we go inquire cast unit, and we can see that, although we've added a lot of bars, we've got 2 types of L. The one we've duplicated has duplicated the value, so it's got 34. The special one on the outside is a 17. You see the one with the 2 equal legs of 950, and then we have those rounded ones that are again 34. So it's going pretty good at the moment. So let's move on to the verticals, and what I'll do is I'll do this side first. So if we go crossing bar, rebar sets obviously, and I go to, let's pick a, the engineer is asking for a N24 it seems. So if I go N and I go 24 as a main bar and I say okay, and then again traditionally we'll pick our class 4, which is the blue color, and the offsets I'm just going to remove them for now. And the exact spacing is calling for a number, and the number is calling for is 5, and the rest can remain. So what I'll do is just hover over the section again, and I pick this. I can also pick this one because, well, let's pick this one and let's pick this one because I don't, they're going to be, actually, let's only pick this one because then what we can do is we can finish the bar off with our end modifiers and our splitter and just copy it or mirror it to the side. So what we can do now is say, okay, we're happy with that. Let's create it. So that will create the bars nicely. And because it's a rebar set, Tekla is aware of the layering. So it puts it on the next layer for us. And that works out really, really nice. So what we can do now is if we click on this bar, we can see that the start, that we had nothing. You can see the brackets here. Although the start is 0, the start's on that side. You see the area? It's Tekla's picked the start on that side. So there it's 0 because it's nicely on that where the arch meets the straight leg part, which is correct. And on the end here, which is this value here, it's picked up 69. So it's again calculated it based on what that bar's diameter is and this radius, and it's picked up the exact value. So with that in mind, what we can do now is we can say, okay, let's manipulate this quickly. Click on the bar, and I'll switch off the leg faces for a minute. Then just make sure we select the bar. I'm going to go to end detail and I'm going to load my defaults because I made some adjustments. I do want a 90 degree, and we know because this is the face, the 90 degree is going to point inward. So what we're going to do is we're going to change this to 180 degrees so we can point outwards. And then for the adjustment type, we're going to do an offset, and the offset is going to be 500 like before. And now that we've got that, we can just hover over the edge here and apply the value, and just like that, it's now got the hook for us. Now, while we've got that setting, we might as well just go and add it to the top as well because it's the same on the top. And that pretty much sorts out that one for us. The next thing we want to do is just introduce the crank splitter. So what we can do is click the bar, head over to our splitter, load our defaults just to make sure we haven't screwed up anything. And then under the split type, we want the crank. And also, depending on which direction Tekla is going to pick, we will have to come and adjust the crank side. But what we can do here is, let's assume Tekla is going to apply what it's doing here. With the length, we want this lap to be on the right hand side, the left hand side, sorry, of the line. So let's keep that. Now, if I hover over here, we can see there's not much happening in terms of, oh, there we go. I've just got to hover over a bar. So let's pick a value of, let's say, 1.5 meters. It seems reasonable. And we can say that is then split and crank the bar correctly for us. Now, just based on what Tekla automatically did with these two, I assumed it's going to do the same with that, and our suspicion was correct, and therefore we could pick the left-hand side correctly for this. If we click on that, we can see that if we look at the direction of the line, the lap is on the left. Okay, so that sort of works out, but I can see that if I just look at that, it's poking out the bottom. So maybe the 1.5 that we picked isn't good enough. So what we can do with this is we can pick that and just drag it up until that blue line reflects 2 meters. And there it is. So with that, it now moves the lap up, and that's probably a more a reasonable assumption. Okay, so with that, what we can do now is we can mirror that about this. So if I can say Control P to make sure that we're in a plan view, we can click on these bars and then right click and say copy, and we can say mirror, and we know that our symmetrical line would be this 45-degree line. And we say copy, and we get those bars replicated on the other side. Now, two things here. The one is because it's picked up that bar, it's moving it again to another level. Actually, no, that's not what's happening. What's happening is, again, with the mirror, it's changed this line direction. So what we can do is we can just flip it around. So it reverses that. And then an interesting trick that Tekla's got is that if you look at these, I mean, because we did a copy mirror operation, we're now replicating this. So what we can do is we can click on this. And if we look at our spacing line, where's our spacing lines? This one, yeah. We can say we don't want this end bar. So if we hover over to the exclude tab, yeah, we can say, exclude the last bar. And if I say OK, you can see Tekla now kindly omits the last bar without affecting any of those. And if we look at this and we do inquire, we can see it's only generated 4 bars for us. So that's the correct number of as well. All right, so with that done, we can then go and move on to the internals, which is a very similar exercise. Again, longitudinal bars. We've got all the right values except that for the number of the engineer is calling for 3, and let's just not exclude anything at this moment. And then if I hover over this end, I can pick those 2 inner legs. Well, let me pick the one and mirror it, because then we can do the changes to the end property modifier. So it's 90 degrees, 180 offset 100. So we can just pick this edge. That's adjusted. We can also pick the top edge. That's adjusted. And now what we can do is we can create a splitter. So if I click on this bar and say give me a splitter, and the splitter has got to be on the right, because I just look at what it's doing there, although it's doing the opposite there, so we don't know what's going to happen here. So but let's just try and see if we can I've got to try and pick up the bar. So there's 1600, 850, 1900, 2 meters. So that's the split. So in that case, it's picked the same direction as we thought, so it's split it in the right place. So that's pretty cool. So that completes that bar. And now what we can do is we can grab this bar and say copy mirror about our symmetrical line again. Just got to make sure that I actually get the right line. There it is, copy. And that pretty much fixes that up for us. Now again, in this we have those clashes here. So what we can do with this, in this splitter, we can say instead of 500, we can go to our 468 again. Actually, that's not correct. Let's try and calculate this correctly. If we look at this bar, it's a 24 bar. So the outside diameter of a 24 bar is 29. So if we take this and we take 29 off our property modifier, so if we go here, so it's 471. So if we go 471, okay, it will miss the bars there. You can see it's perfectly sitting on top. And now what we need to do on the top, to miss it on the top as well, we've got to click on the bar, click on this end modifier and just add the 29 there, so it's 529. Okay, and just wraps it up the top. So that's pretty much kept these bars the same, but we also need to just check the position of the split, because now with that extension, if we now just okay, it's mirrored it. So the first thing is just swap the lines around. Okay, if we now look at the extension, we click on that, we can see that that leg is now changed a little bit. So you can see that it's 271. So if we grab this and we just move up a little bit. Now, if you're getting funny rounded dimensions here, what you could do is you could also hold in your shift key and you'll get rounded dimensions. So if we go, what are we looking for? We're looking for, maybe zoom up here. So that's going to be 21. So we need to come down. And if we zoom in a bit more, we could possibly get that 1 millimeter down as well. It's strange that let's see if we can be pedantic about this and actually, oh, there we go. That's exactly 2 meters now. Look at that. So, okay, with that in mind, what we've done now is you can see the splice has moved up a little bit. And the reason for the move up is because we're going on top here. So we're basically just moving the whole lot up. And theoretically speaking now, if I click on this and I go right click and I go inquire cast unit, we have not increased the number of bars. We do have a L with a 2000 and 399 leg for some reason, and then the others are obviously 12 bars. That's from the thing is, but the point here is that it looks like we've got all our bars, which is 15 of them, which is the verticals all in one line. So if we look at that, let's just do a summary here. We've got 5 bars there, we've got 6 bars here, which gives us 11, and then we've got another 4 there, which is the 15. So that way we keep the number of things in the bending schedule, lines in the bending schedule, to a minimum. So having done that, what we can do now is focus on the on these circular bars. Now they're very easy. The way I would approach this is just to use the guideline again. If we go guideline and we make sure that our values are correct, and it's 3 bars, okay, everything is correct. Now I've got to pick a face, and if I pick a face, I pick that face, middle mouse button, and then Tekla is asking for our guideline. And with the guidelines, I like to start at the top, so I'll pick this edge and I'll end, just make sure that I end at the right edge. So if I just try and rotate around here, I want to end at this edge here, middle mouse, and I want to do the same at the bottom. So if I start at this edge and I go around and I end at this edge. Now the reason I'm doing that, and I'll middle mouse, so it creates the bar. The reason I'm doing that is, although if you look at this bar, if you click on this bar, and I'll also switch on the rebar visibility leg faces, if I switch it on, although it's picked all of this as a leg face, the spacing line only goes from here to this. So it's only going to put bars into this zone. And at the moment, if you look at that, the bars, look pretty silly, because we need to apply a follow command. So if we click on this spacing modifier, we go down to follow. It will then follow the arc first. And if we go down the bottom and apply it to this spacing as well, follow, it follows the arc. And now what's happened, if we go into a view, we then have the 3 bars. So we can see there's the one, there's one there, there's one there. Now we've asked for 3 bars going from there to there, and we have a 0 and a start offset. So if we change the offset and we add 150 mils to the start and 150 mils to the end, it should move this bar 150 up and this one 150 up. And if we say modify, that gives us the outcome. Now, because this is a guideline, you've got to do the same at the bottom, because it's now applied to that guideline. And if we go down the bottom and we click on this guideline, you'll see again it's got different values. So in here we do 150 here, and we also do 150 here, and now we have those bars perfectly formed around that radius. So if we look at that, we've got our 1, 2, 3 bars with our flow line, and it's exactly what we want. The next thing we can do is to just add our property modifier. So if we click on this bar, and I'll switch off the face because we don't need it anymore. If we click on this bar, we can go end modifier, and again we want a 90 degree, 180 with an end, and we can go back to our 500 because that's not going to clash with anything. And now if I pick, you'll see nothing happens if you sort of hover over it. We've got to pick our point mode, and we pick this edge to that edge, and we say accept, and make sure if we click on this that we apply the flow so it goes around. So then these get fanned out 90 degrees exactly, and we can do the same in the top. So if we go into the top, we can apply our end modifier from this edge to this edge, middle mouse, and that applies it. Now you can see it looks all funny, and as soon as we click on that and say apply to the flow, it looks much better. So if we look at Control P, that's given us the desired right. Now this won't always be 90 degrees. It just depends on how it works out the spacing. You could get it there, but I don't think for the sake of speed and outcome, it's not going to change your bending schedule. It's probably not worth trying to achieve that. You're just going to play around with numbers all the time, so just leave it like that. Okay, so all we need to do now is add the splitter. Now the splitter again is a bit of an issue, so let's see how we're going to deal with that. Again, in this regard, we don't have a point to snap to. If we click on it and we go splitter and we make sure that we're in single point mode, we can see it doesn't follow the bar because it's a guided face. So again, I'll do like I did in our first video on columns with the tapered columns. I'll create a plane. So if I go to edit, construction plane, plane. Make sure that my snap to any position is on, and I'm working in a plan view 0. What I can do then is just quickly draw a work plane that I'll need here, 2.2, and then middle mouse. And again, just for a refresh, if you don't see the plane, make sure if you click, make sure that you've actually got your construction planes set to I can see it, it's visible. And secondly is if you can't select them, make sure that down the bottom here with select planes, you've got it enabled. Now that we can pick those, we can say right click and we can say move special linear, and we want to add it to the others, which is like actually we want to hit the top of that bar, so let's just cancel out of that. What we want to do is we want to meet this, and because we've got 2 meters on the total length, I don't know what's left. Yeah, so it should be about 1.5 meters, but what we can do is we can say move linear and then pick this point and then pick the top of the bar, and it will work out exactly what we need. All we need to do is 0 the X and the Y, and if we then say move, that plane will now be moved. And the reason we don't see it is because we in if I could just put on my visualization, this is our scope of what we can see in this model. So if I clear that out and we go back to our 3D rendered mode, we can see it's now placed that exactly on top where we want to cut. These will be a bit higher because of the fact that we've pushed these bars up, remember, but the others are all on the same level. So, okay, with that, what we can do now again is go over to our applications components. In there, we can type line, and then we can use this component. So if I click that component, the way it works, it wants a vector. So if I pick a direction, and the direction would be from here, make sure that we pick our blue axis, make sure it's blue to there. And now that it's got the vector, we need to give it the 4 points on the plane. So if we pick that point, and we pick the back point there, it will then, obviously the first time a component runs, it takes a bit longer because it's got loaded into memory. After that, it's pretty much instant. And while I'm in the command, I'll just go it out. You've got that point now. While I'm in the command, I might as well do the other edge as well. So if we go down here, make sure we got that edge. And then all the way to the top, make sure that we've got our blue ortho, and then pick that point. And now that we've got the vector again, we can just pick out 3 corners of our plane, and then instantly it generates a second corner for us. So now that we've got that, it's as easy as we grab the ball, and then we can go to our splitter. And then what we can actually, before I do that, I need another one in the front because a splitter can't follow a edge. There is no edge to follow here, so we need at least 3 points, and then we can change the node of that point to a tangential arc. So what we can do then is to say we need another line that goes from this point here, and make sure that we have our blue axis. Where's the ortho? There's the ortho, and just move down till we get the point there, and then again just pick our 3 corners of our plane. It generates the third one that we want here. So okay, now we don't need the plane anymore. We can delete it, and we've got our 3 points. So what we can do now is finally pick our bars, add a splitter, make sure that we see our property pane, and in the splitter we're going to go around this way, so we want it to be on the right hand side, which is correct. So if I click this point, oh, we've got to be in point mode, I beg your pardon. So if we click that in point mode, we can click this point, and then that point, and then lastly that point, and say middle mouse, we can get our splitter. It splits the bars, as you can see there. And now just to get this to flow around like the others, because if you click on this line now, there is actually a flow. If we do flow, but it can't flow. Why won't it flow? Because there's no edge there. So to get the same result, we can click on this node, and then we can change the rounding of the node to an arc point. And if we do that, we get the same result as a flow. And now we can see how nicely it's split these bars with a crank around that nose. Quite a complicated process, but same result again. Now I'm just curious to see if we click on these, right click inquire. So we did meet our 200, now 300 like before. So it's pretty much good and trusted. So what we can do now that we have that, we can pick this bar and we can say right click. And again, if you can't right click, go and look at your selections at the bottom. Now we've got groups because I selected the bottom. So if I go back to rebar sets, click on these, right click, copy special mirror, and we'll use our intersection here again. Copy, and that will give us a group of bars over here replicated. And again, because we mirror, we've got to look at our direction of our line. So if we click on this, we can just swap the flow and it fixes up our cranks to the right direction. Now that pretty much completes the exercise. We've done it all. It was interesting for me. I hope you guys learned something, and I think there's benefits to using rebar sets in terms of layering and working with end modifiers and rotating bars that you don't normally have with rebar groups. I mean, if you look at a rebar group, you can rotate the hook, but if you can't rotate the bar itself. Where with rebar sets you can do a lot of magic, but the rebar groups has their place too. Like for instance, in this bar, it was really interesting to create this with the rebar group and get the same result as the rebar set. So you can pick which method you want to use, whatever you are detailing, and I'm sure you'll come up with a very optimized way. I hope you enjoyed that, and see you in the next video.